So we start the lecture number 3 for 8051 microcontroller series. Those who have not seen can go and see the previous lectures, and we are going to upload the complete full-fledged series on 8051. So now in today's discussion, we'll discuss on what are the basic selection criteria for selection of microcontroller in an embedded system. Now we discussed in previous lecture that in embedded system there can be microprocessor, there can be microcontroller, but now we assume that most of the embedded systems have microcontrollers. So what criteria will you use? Suppose you want to develop some embedded system. For example, you want to develop some timer which we can set from external world. Okay, on time, off time, whatever. So for development of such a embedded system, what microcontroller you will select, what criteria you will follow, that we are going to discuss. One thing that I want to explain is the basic microcontrollers in the market for at least 8-bit or 16-bit, we can say that 8051, then Zilog, and then PIC microcontrollers. These are from Microchips. This is from Intel. Then Renesas is again a good company in the microcontroller field that has, suppose for example, RL78 series, then Motorola. These are all examples of various microcontrollers available in the market. Now you want to develop an embedded system. Which microcontroller you will select, that will be decided on number of factors. The first and most important factor is whether that microcontroller is 8-bit or 16-bit or 32-bit. Now what do you mean by 8-bit microcontroller? What do you mean by 16-bit microcontroller? 8-bit microcontroller means, as all of you know, that microcontroller is based on digital electronics, and digital electronics is based on 1 and 0. Okay, so there is binary number system inside, what you can say. So when you say that microcontroller is performing addition, it is performing addition on binary numbers. There will be by adder that will be developed using a digital electronics. You must have studied digital electronics. Of course, we are assuming that those who are looking these lectures have basic knowledge of the digital electronics. Okay, we can upload some videos on digital electronics as well, but for now you can assume that bit is a binary digit. Now 8-bit microcontroller means its ALU, arithmetic logic unit, is basically 8-bit. So it can perform 8-bit addition, subtraction, like that. They say microcontrollers don't directly perform multiplication. Actually multiplication, what we can say, maybe you can say successive addition. If you want to perform 4 into 3, oh, you can do it 4 plus 4 plus 4 3 times, like that. Okay, so basically there is adder and subtractor. Okay, so 8-bit microcontroller means its arithmetic logic unit is 8-bit, which can perform 8-bit addition, 8-bit subtraction, like that, or ending or in logical operations as well. Now there may be 16-bit microcontroller, there may be 32-bit microcontroller, depending on that ALU size goes on increasing. Again, second important point, the registers inside. Now registers are microcontrollers internal memory, what you can say. It's like a memory actually, which can store the data actually. So suppose there may be registers named as A, B, C, D, like that, and these registers mostly 8-bit if it is 8-bit microcontroller. So in one chunk it can store 8-bit data, like that. So there may be 16-bit registers, 16-bit ALU, depending on whether it is the microcontroller is 16-bit or 32-bit, like that. So this is most important criteria, whether you want 8-bit, if your task can be, we can say, more, the calculations are lengthy, or you need 16-bit chunk of data, so you want that performance, you can go for 16-bit or you can go for 32-bit. Now what about the speed? Speed is decided by the frequency on which that microcontroller is working. Now the frequency may be decided by some external crystal or all that, but there may be some maximum limit. Maximum limit, like a particular microcontroller can work on 8 megahertz, particular microcontroller can work maximum on 16 megahertz. So 16 megahertz will be the clock, and depending on that clock, see, the operations inside are synchronized to the clock. So the operations are, you can say, the speed of microcontroller will be decided on the maximum clock on which it is working. So this is again important factor. Now packaging, like it may be DIP, dual inline package, or called flat pack, or what type of packaging, the chip, how that chip is there. We will come across all these things as we go on discussing lectures, but for now how that chip is, what type of packaging is used, that is again a factor. At the time of designing a PCB, you consider what type of chip you want, what type of PCB you are designing, like that. Now, what is the power consumption of that microcontroller? This may be critical factor for battery operated embedded system. For battery operated embedded system, yes, we should think on the power consumption, because the power consumption is more, your battery will drain early, so you need a frequent charging. Now, what is the cost of that chip? Then you can understand, you have to compare the cost also. Then how much memory is there, how much RAM is there inside, how much ROM is there inside, how many registers are there, like that. Those things also we consider. Okay, depending on the code size, if your code is big one, then you will go for more memory, like that. Actually the code will be stored in a you can say EEPROM type of memory. So depending on your code size, you will decide whether you want how much kilobyte or how much megabyte of memory for your particular application. Okay. Now availability of developing tool. See, you go in the market and you take one chip and that is finished. It's not like that. You need some development things. Even for programming of microcontroller, you need a computer actually. On computer you can install some kind of integrated development environment, and that integrated development environment will have editor, compiler and all this software. Okay, so whether the compiler is available or not. Now what is my compiler? See, programming of microcontroller you can do in, you can say, assembly language, or you can do in embedded C or any higher language, right? So that program needs to be converted into machine language. So for that you need a compiler, actually debugger. You should able to debug, you should able to do the execution of program step by step and see what it is doing, like that. So you should able to download that program from computer to that particular chip. All these tools, programmer and all these, their availability you need to consider, you need to think whether they are available or not, like that. Then in market, whether the chips are available or not, what kind of technical support that company is going to provide you. Okay, is there any website or is there any technical, you can say, community? These are all important factors you need to consider for selection of microcontroller in embedded system. In next lecture, we'll be actually starting 8051. Thank you for watching.